Welcome, this is your 5-minute geography lesson. We're covering Theme 1, Element 14, Changing Landscapes. Thinking hats on, I'm Mr. S and I'll be your 5-minute teacher. The rate at which the river or coastal landscape may change can be due to a number of different factors. These include geology, the climate, extreme weather events and even human activity. But to start with, let's look at geology. Now we've looked at this a lot, particularly in terms of our coasts in past lessons. But we know that we have harder and softer rocks. And in the UK, our softer rocks tend to be the clays and sands, and our harder rocks are chalk and limestone. The clays, the softer rocks, tend to be loose, not very well packed together, and so they're more prone to erosion. And that can be on the coast or it can be in the river. Whereas the things like chalk are rather dense, they don't have very large air pockets in them, and therefore they're more likely to withstand erosion, or better at least than the softer rock. But we can also look at this in terms of how the geology is structured. So particularly on coastlines, when we look at things like what we were calling concordant and discordant coasts, which we can see here, we have an example of both. So along the south coast here, this is a concordant coastline because there's only one layer of rock facing the sea. Whereas on the east coast here, we've got a discordant coastline and we've got layers of both hard and soft rock alternating up the side of the coast. So our concordant coastline is more resistant to erosion because we've got that harder rock in place. Whereas our discordant coastline is more likely to see erosion because it's got those alternating layers as well. Next we have climate. So the climate is our weather over a longer period of time. So we can look at this in two ways. So we know that in the summer we tend to get warmer weather and no storms or very infrequent storms, and in the winter it's colder weather, it's wetter, and we're more prone to heavy winds and storms. So we know that we're probably going to get more rate of change, more erosion occurring along rivers and coasts in our winter than we are in our summer. So wind can have a dramatic effect on waves. So the stronger the wind, the more power our waves have. So in 2014 we had a winter storm which flooded a lot of the south coast in terms of the coastal areas, and it also disrupted transport, it took down power lines, and it even destroyed parts of the East Coast Railway. So that would influence whether the waves were constructive or destructive. So more wind means that we're going to have higher and stronger waves, which is probably going to mean that they're going to be destructive waves, which leads to more erosion as sand is taken off the beach or it batters sea walls. Winter weather and summer weather can also be influenced by climate change. So our usual is not always the same now, as we're starting to see increasingly warmer weathers in the summer and we're getting more intense storms in the winter. So this leads us on to our next factor, which is extreme weather events. So these are the ones that are completely out of the ordinary. And we often describe these things as being things like once in 25 or once in 50 or once in 100-year storms. Things that have only happened once every so often. And one example of this is Storm Desmond in 2015. It flooded large portions of the west coast, Cumbria being very badly hit. So powerful storms can increase the destructive nature of both waves at the coast, but also increase the amount of water that ends up in a river, and that means that that river then has more potential to flood or to erode and cause the events like we saw in Storm Desmond. And then finally we've got human activity. Now we can split human activity into two areas. Human activity can have a benefit in terms of it can try to resist that change that's occurring naturally or from humans, and it can also have a negative, and we're going to start with that now. So you can see an image on the screen, and this is a footpath beside the coast. So you can see the public footpath and the gate leading down here. As a direct consequence of this being a popular footpath, it's weakened the top of the cliff, and you can actually see some mass movement here. So this is an example of slumping, rotational slip, where part of the cliff face has been weakened and then it's forced that to slip down. But humans can also have a benefit, as discussed. So we can put management in place to try and stop change from increasing or stop it all. So for example, on rivers, we might dam rivers to prevent flooding downstream. We might plant more trees, which is called afforestation, and that would anchor soil in place, but also it would intercept, so stop some of the water before it reaches the river, or slow down the rate that water reaches the river. On the coast, we might build groins. So groins are fences that run from on right angles to the coast all the way down to the sea, and that stops longshore drift from taking sand further down the coast, so it stops the beach from disappearing. So there's lots of ways in which humans can both benefit and have a negative influence on our rate of change. Well, that brings our lesson to an end, but continue at your own pace by completing the Now Try task for homework. Class dismissed.